Another important factor that influences hemodynamic function is vascular compliance. So the compliance or capacitance is really the measure of distensibility of a vessel wall. So it's a measure of the pressure-volume relationship in the vessel wall. Compliance is related to that distensibility or the ability to expand, and it can be calculated by this equation where compliance is equal to the change in volume divided by the change in pressure. And the compliance of a blood vessel really describes the volume of blood the vessel can hold at a given pressure. And the equation shows that the higher the compliance of the vessel, the more volume it can hold for a given change in pressure. So if we think about some real-life examples of compliance, first, if we consider a plastic shopping bag that's crumpled up, it's really easy to fill that plastic bag up with air, for example. So we can increase the volume here without a big increase in pressure, which means that the plastic bag has a very high compliance. These uninflated party balloons, on the other hand, are elastic, so they're stiffer, they're more resistant to filling, and they require a great deal of pressure to fill, and therefore have a lower compliance. So now if we think about compliance as it relates to blood vessels, we can think about veins being like the plastic bag. So they're very compliant, they're easily able to be filled with blood with little change in pressure, while arteries are like the balloon, so they're elastic and more difficult to fill. And that difference is shown on this graph of pressure versus volume. So the compliance of the veins is this dotted upper line, and the compliance of the arteries is this solid line. And we'll first mark this starting point of pressure and volume here in blue. And that starting point, there's the same pressure and volume in both the arteries and in the veins. Then if we add the exact same volume of blood to either a vein or an artery, we'll see there's a very different change in pressure as a result of that added volume. So the more compliant veins have a relatively small change in pressure as a result of this added volume, while the arteries, on the other hand, have this much larger change in pressure as a result of the same amount of added volume. So the steeper the slope of the line on the pressure volume diagram, the greater the compliance. And this just means that it's easier to increase the volume here in the veins, and that the veins can accept relatively large volumes of blood with very little buildup of pressure. And because veins act as these volume reservoirs, they're sometimes referred to as capacitance vessels. And briefly, as you can kind of see here with this lower line with the flattened slope, arteries become even less compliant with age, meaning there would be an even greater increase in pressure as a result of the same change in volume in these aged atherosclerotic arteries. Compliance, as we'll see, is also important in the heart.